In this video, we're going to look at forces, and in particular, we're going to look at how to resolve forces. So, if a force is applied at an angle to the direction of motion, we can resolve it to find the components of the force that act in the horizontal and vertical directions. So, in other words, if we just look at this diagram here, we've got a box lying on a flat surface and a force which is being applied at some angle to the direction in which the box would move. So if we just highlight in there the direction of motion, so we would expect the motion to take place in this direction, there is a component of that force acting in the horizontal direction, and there is a component of that force acting in the vertical direction, because this force here, we can split that into its horizontal and its vertical components, where we've got some angle theta between that force and the direction. So if I start with this component in the x direction, I'll just label that as x and this as y. So our component in the x direction, we've got the adjacent side here. So we know that cos theta is equal to the adjacent side, which is x, over the hypotenuse of this right angled triangle, which is f. So if I want to find x on its own, I can multiply both sides by f. So I get that x is equal to f cos theta. So in other words, the component in this direction is equal to f cos theta. If I was to do the same with y now, so here this time I've got the opposite side, so sine of theta is equal to the opposite side y over the hypotenuse f. So again, if I wanted to find y on its own, I can multiply both sides by f and get that y is equal to f sine theta. So the horizontal component, the adjacent side, is going to be f cos theta, and the vertical component, the opposite side, is going to be f sine theta. So if we look at a couple of examples based off that then, so we're being asked to find the component of this force here in, first of all, the x direction, then the y direction, and then we're being asked to write that in IJ notation. So the first part, the component in the x direction. So if I'm considering the component of that force acting in the x direction there, so I'm just going to call that x. Well, again, from what we did before, we have that this is the adjacent side. So for part A of this question, I've got that x is equal to f cos theta, because we've got an adjacent side. So that means it is equal to, the force was 8 times cos 30. So in our calculator, we can do 8 lots of cos 30, and that is going to give us 4 root 3. So I've got there, that is equal to 4 root 3 newtons. Now for part B, we're being asked to find the component of the force in the y direction. So that's going to be this part here. So again, from what we did above, we've got that y is equal to f sine theta. So that is going to be equal to 8 lots of sine 30. We could put that into the calculator, or we could recognise that sine 30 is a half. So that's going to be 8 times a half, which is going to be equal to 4 newtons. So finally, for part C on this one, they are asking us to write the force in the form, and so IJ notation, where I and J are the unit vectors in the x and y directions. So we can just simply write that as 4 root 3 I plus 4j newtons, and that's just writing that in that component form as a vector. So the second example now. So we're told that two forces P and Q act on a particle as shown. So we've got the force at P and the force at Q. And we're told that P has a magnitude of 10 newtons and Q has a magnitude of 8 newtons. And from there we're being asked to work out the magnitude and direction of the resultant force. So first of all, if we look at this diagram, we can consider the forces separately and resolving them into their components. So if I think about this force P, which is 10 newtons, the horizontal component of that, since I've got the adjacent side here, I've got 10 cos 45. So this is going to be 10 cos 45. And then we also have the vertical component, which is going to be 10 sine 45. So 10 sine 45. If I consider the force which is 8 newtons, so this force Q, the horizontal component of this force, also going in this direction, is going to be equal to, again, the horizontal component in this triangle is going to be an adjacent side. So there I have 8 cos 30, and the vertical component this time going down the way is going to be the opposite side, so that is going to be 8 sine 30. So we've got all of our forces resolved into their horizontal and their vertical components. So now if I think about resolving in the horizontal direction, well, in the horizontal direction I've got 10 cos 45 plus 8 cos 30. So I can do 10 cos 45 plus 8 cos 30. So in my calculator, 10 cos 45 plus 8 cos 30. And that is going to give me 13.99, very close to 14. So we'll go 14.0 newtons. So that is our component in the horizontal direction. Now in the vertical direction, I've got 10 sine 45 here going upwards and 8 sine 30 going down the way. So I'm going to subtract 8 sine 30. The reason I'm subtracting there is because 10 sine 45 is in the upwards direction, whereas 8 sine 30 is in the downwards direction. So again, in my calculator, we can type in our 10 sine 45 subtract 8 sine 30. So 8 sine 30. And when I put that into the calculator, it is going to give us 3.07. So that is equal to 3.07 newtons. So we've got our forces resolved in each direction. So the question is asking us to find the magnitude and the direction of the resultant force. Now we've got our resultant force in its horizontal and vertical components. If I think about what that force looks like, we've got 14 newtons in the horizontal direction, and we have 3.07 newtons in the vertical direction. So that resultant force I can represent as a vector looking something like this. So that's going to be our resultant force. So I can find the magnitude of that force using Pythagoras' theorem, because we've been able to form a right angle triangle there. So the magnitude is going to be equal to the square root of 14.0 squared plus 3.07 squared. So we've got our right angle triangle there. So we can do in our calculator 14.0 squared plus 3.07 squared, and it's the square root of all of that, which is going to give me 14.3 newtons if I go to one decimal place. The direction of our resultant force, but if I take this angle here to be theta, our opposite side and the adjacent side are 3.07 and 14, so opposite over adjacent is going to be tan, so I can use inverse tan of 3.07 over 14.0. That's going to allow us to find our angle. So if I do inverse tan of 3.07 over 14.0, and then that is going to give us 12.4 degrees. We'll round that again to one decimal place, and in particular it is 12.4 degrees above the positive x-axis, because specifically that angle is in this direction here. So that there is our answer to that question there. That's our video on resolving forces. That's the end of this video. Thank you so much for watching. For more A11 GCSE maths content, like and subscribe to N Jackson Maths on YouTube.